Hi everyone, this video is going to be on chapter 11, which is on solutions, and these are the calculations which are found in section 11.1. The whole chapter is about solutions, but they put most of the not all, but most of the calculations are in the first section. We'll do more calculations later. And so what this section is about is just going over some different units for concentration of solutions. So this is found right now going to be on this is going to be in the packet, and it's going to be on page 123 and 124. It's not in a PowerPoint because it's just some calculations. This homework that I have listed here is just for this section. There's more homework listed in the PowerPoints. There's 2 PowerPoints for this chapter. After this, all of this stuff is in packet 3E. But the PowerPoints are on the other sections. There's going to be 2, so I'm going to do some more videos after this one. This is going to be the calculations from section 1 only. So before we jump in, we want to remind ourselves, since we're talking about solutions, that solutions are homogeneous mixtures of 2 or more substances. Homogeneous means it's same throughout. You can't see any different phases. If you were to analyze a sample from, let's say, the bottom and the top of the solution, they would have the same concentration. You can have more than 2 substances. There's 1 solvent, but there could be more than 1 solute. So let's review that though. In the solution, the solute is dispersed uniformly through the solvent. So the solute is being dissolved, and the solute is being dissolved. The solvent is doing the dissolving. There's an S here because what I was mentioning, you could have more than 1 solute. For example, tap water has calcium, magnesium, hydroxide, hydrogen ion, chlorides, all kinds of stuff in it, though solvent is water. So the way we express how much solute is in the solvent, is it a very dilute solution, is it very concentrated, is by using concentration units. And you're familiar by now with molarity, which is moles of solute per liter of solution. So if you only have 1 solute, you can do just the molarity of that 1 at a time. You could have a total, let's say if you had an ionic solution, you could have the molarity of all the ions depending on how it's worded. Usually it's 1 solute at a time, so moles of sugar per liter of solution. Another way to express concentration, we actually saw in gas laws when we had mixtures of gases. And that is to take this is called the mole fraction. So this is our mole fraction here. Mole. So that's the mole fraction. And we learned it in the gas laws chapter 5 that the mole fraction of A is the moles of A over the moles total, where A is one of the components of the solution. A could even be, if it's a solute, then this is considered a concentration unit. You could actually have the mole fraction of the solvent as well. Doesn't matter here. In this case, A is just any part of the solution, any one component of the solution. Another way to express concentration is just to do it as a percentage. You can do that percent by mass, so a mass percent. And this is to show you percent M over M means mass over mass. And the way you do that is you take the mass of the solute divided by the whole thing, the mass of the whole solution, and then times 100 to give percent. And sometimes we do it in volume, percent by volume, and sometimes you see this on like beer, percent alcohol by volume. And the volume percent would be the volume of the solute over the volume of the solution times the 100. And we use this a lot when the solute itself, the thing you're dissolving, is also a liquid. So if it's a liquid solution, a liquid dissolved in another liquid, this is kind of convenient. If it's a solid dissolved in a liquid, a lot of the times we use the mass percent. We're not going to do any calculations with volume percent. I'm just putting it here to be complete, so you don't have to worry about that in Chem 200, just showing you where it comes from. A weird one that you probably haven't seen before is this little m, because, you know, we need something else with a little m, right? We got mass, we got meters, we've got milli, got all kinds of stuff that in moles starts with little m, but unfortunately they use the same letter here, and it's molality, not molarity. It's one letter different. That's an R right here, and this is an L, molality. Molality is, to get that, you take the moles of the solute, the thing that's being dissolved, and you divide by the kilograms of solvent. So this one's the only one of all of these where the bottom, the denominator, is the solvent only. Here we have liters of solution. Here we have moles total, so that would be of the solution, of everything that's there. Mass of solution, volume of solution. So all these reflect the whole solution, solute and solvent together. Here it's just the solvent. So that's the only one that's a little bit different. Why do we need another one if we got all these? Well, this is going to be used in certain formulas that we see a little bit later on in the chapter, where it requires us to have the molality in there. So it's used in certain physical formulas that we need. It's required to have molality. One thing about molality that's sort of kind of better than molarity, if you want to think of it, because this has a volume in it, volumes can change with temperature. If you take a solution and you warm it up, a liquid, and you warm it up, it's going to expand because things tend to expand when they get hotter. If you chill it, it's going to start to compress a little bit. So the volume can change, which means the molarity would change if you heated it a lot. Now, that's not a big factor. We don't usually worry about it in a normal lab situation. But when you're heating things to high temperatures or going down to low temperatures close to freezing, then you can have the molarity can change just with temperature. With this, because moles doesn't change with temperature, mass doesn't change with temperature. So molality is more of a constant concentration, which is why it's going to be used in some of these formulas that require a physical change or a physical constant going on. And you'll see as we get to it. So it's not something you normally would label a bottle. If you had a solution of, let's say, acid, you would, maybe 2 molar acids, you'd say. You wouldn't use molality. It's more for calculation purposes. Okay, we'll get to that in a minute. So we're going to use most of these. We're not going to do the volume one. We're going to use most of these in a minute. So over here, as I mentioned, this is the homework for this section only. There's going to be more homework for later sections. So let's get to some calculations. So this now is on page 124 of the packet. And we've got some problems, I call them lecture problems here. And so we have a solution that's being made, and it says 15.6 grams of this molecule. It's long, lots of carbons and hydrogens, but it's an alcohol because it has that OH in it. When we have an alcohol, it has an OH that's covalently bonded, not a hydroxide, but it's a covalently linked. Even though it's on the end here, this is going to be, this oxygen will be bound to a carbon if you were to write out the whole structure. This is sort of like a compressed little structure here. So we got 15.6 grams of lauryl alcohol, which is this. This is its molar mass, so I did that to have a little bit convenient here. Was dissolved, okay, so that means this is the solute, and now this is going to be the solvent. Was dissolved in 148 grams of ethanol. Here's the formula for ethanol, and here's its molar mass. To make things easier and not to write this out, for lauryl alcohol, I'm going to just abbreviate it LA. For ethanol, we usually abbreviate it like this. ETOH, ethanol. It's a very, ethanol is the alcohol that we, is in fermentation. So you find it in wine and beer and alcoholic beverages. It's what they add to gasoline. It's found in, from fermentation. So it's a pretty very, very, very common chemical. So that's its normal sort of, it's not a formula, it's abbreviation. All right, so we want to calculate the molality of the solution, molality. And if we go back to the previous page, we see that molality, let's go look at it again. Sorry, one second. There we go. So down at the bottom, molality is going to be moles of solute per kilogram of solvent. I'm going to replace that with what we have. So our solute here is lauryl alcohol. Solvent is the ethanol. Okay. So the molality will be So it's important to get your definitions down and have those ready or handy or know what to do in order to do these calculations. So we need moles of lauryl alcohol to do this, and we have grams. So we have to do a grams to moles calculation. We need kilograms of ethanol, and we have grams. So we have to do a little unit conversion. So the moles first. 15.6 grams lauryl alcohol. Its molar mass is that 186 here. And that is 0.0837 moles of lauryl alcohol. I'm just going to round it to the 3 sig figs. When I do this in my calculator, I keep more sig figs than that. So I'm just writing it down for purposes of doing it quickly here. But in my calculator, I have more digits than that. And then we have the kilograms of ethanol. So we need 0.0837. For kilograms here, you have to divide by 1,000. So 1 kilogram, I'm sorry, 1,000 grams in 1 kilogram, like that. And so 0.148 kilograms. So if I divide that 0.0837 by 0.148, I will get 566 little m. If you were reading it out loud, which you probably will never have to do unless you teach chemistry class, you'd read that 0.566 molal. Okay, so that's the first one. What is the mole fraction of lauryl alcohol? Oh, by the way, I want to mention something before you do that. Notice how this says molality of the solution. This confuses people sometimes because it says of the solution, and then for this I used lauryl alcohol as the solute. If it says it, there's two different ways to say this. I could say, what is the molality of the solution? It implies that it's solute over solvent. I could say, what is the molality of lauryl alcohol in the solution? And that would mean the same thing and be very specific. Since there's only one solute here, I don't have lauryl alcohol mixed with something else, I can just say molality of the solution. But if I had two solutes, I would have to be specific, so don't let that confuse you. Now, on the next one, I have to be specific because mole fraction can be done for either the solute or the solvent because it doesn't have any specificity like molality does with solute over solvent. So I have to say the substance. So mole fraction of lauryl alcohol. If I go back to my paper here, it's going to be the moles of lauryl alcohol over my total moles present. And the total moles are going to be moles of lauryl alcohol plus my moles of ethanol. If I had 4 things, I would have to add them up. So just like you did in the gas loss problems where you'd have to have the total. So I already have moles of lauryl alcohol from this step. If I was only doing this problem, of course, I'd have to do that. But now I need my moles of ethanol. So I know it's grams and I know it's molar mass. That comes out to 3.21. So my mole fraction will be my moles of lauryl alcohol plus my 3.21 moles of ethanol. Units on top and bottom is both moles. So this is unitless when you do the final answer. And it comes out to 0.0254, my mole fraction of lauryl alcohol. Okay. Mass percent of lauryl alcohol, that's pretty easy when you have mass data. Mass percent is going to be my mass of my solute divided by mass of solution times 100. Oops, my screen froze. Give it a second to catch up. Okay, so you can write percent by mass or mass over mass. Percent by mass is going to be the grams of lauryl alcohol over the grams total. 100. And that is my lauryl alcohol was my 15.6. And my solution is 15.6 plus 148. And if I do that, this bottom part is 163.6 grams. And then if I divide, and then if I divide 15.6 by 1, let's do that, 15.6 divided by 163.6 times 100, that gives me 9.54% lauryl alcohol. This is one place where the wording can get confusing. I could have also said, what is the mass percent of the solution? Because it's implied in the definition, because it's solute over the solution, that if you don't have to say the name of the solute, you just say, what is the percent, what is the mass percent of the solution? What is the percent of the solution? You would understand it to be the lauryl alcohol, because that is the solute. I was just being specific here. Okay. Those are all pretty easy ones. This next one's a little bit difficult, not really that hard. It's just a little bit more steps. And now we're gonna find the molarity, which you're like, hey, I've done molarity a bunch of times before. That's easy. Well, the problem is though, if you remember, the data that was given to us in this problem is all mass. And for molarity, we need liters because it's moles per liter. So when you're given mass data, or sometimes you're just given a mass percent. Okay. So whether you're given the masses, the grams themselves, or you're given the percentage by mass, in order to get to molarity, you need a density, because density converts grams and milliliters. So we want molarity, which is moles of solute per liter of solution. Okay, so in our case, it's moles of lauryl alcohol, liters of solution. All right, if we go back up here, I have my moles of lauryl alcohol. But what I don't have is anything to do with liters of solution. But over here, I know how much the whole solution weighs, because this was the total of everything. The solution is just everything put together. So I can use the density to convert this grams here, this 163, I can convert that to liters. So that's what I'm going to do down here. 163.6 grams of solution. And, you know, if you learn how to do density calculations with a little triangle or with, you know, trying to do algebra, forget about that. Okay. No chemists don't do that. We just use unit conversions like these in order. You can think of density as a conversion factor. It's just, it's only specific to that one thing that you're talking about, in this case, the solution. So if I know grams of solution, and I want to get to milliliters, this tells me there's 0.850 grams per 1 milliliter. So you don't have to think about multiplying or dividing or doing an algebra problem. The units guide you like that. Now, we also are going to want this to be in liters because that's what we need. So 1,000 milliliters is 1 liter, or I could have said 1 milliliter is 10 to the minus third liters, however you normally do that. In any case, it comes out to 0.1925 liters. Okay. Really has only 3 sig figs though. Because of this, it only has 3 sig figs. So my molarity, go back and take the moles from up here. Oops, sorry if you can't see that. 0.1925 liters. And if I divide that, comes out to 0.435 molar, 0.435 molar solution. Okay. So that's all that we're going to do in this video. I'm going to show you one more of these and show you a different way to do it using the mass percent, because you might run into that in the homework. Like, what if we didn't have, so in other words, if you were given a problem like number 4, but you didn't have all this done already and you were only given this, what would you do? So you're going to get the same answer. I'm just going to sort of set it up and show you. There's a 5th problem down here, but we need to do some more PowerPoints on some concepts before we get to that. So we will return and do number 5 after a couple more videos. We'll come back to that. But first, I want to show you how to get this if you were only given this number and the density. So I'm going to flip the paper and do that. So if we said something was 9.54% lauryl alcohol, so a solution is 9.54% lauryl alcohol, period. Its density equals, okay, so its density is the solution's density. We're not talking about the density of lauryl alcohol or the ethanol. We're talking about the density of the solution itself. You're doing experiment 13. That's the same thing that's happening there. So the solution's density is you make the solution, you mix it together, and then find the density. So example would be salt water. The density of water is about 1 gram per milliliter. The density of salt water is higher, so you have to make the solution, and the density depends on the concentration. So if I had a different percent of lauryl alcohol, 15%, 5%, it would have a different density. It depends on the concentration. So that has to be given to you. All right, so, and then the question is, what is the molarity of this solution? Well, a couple different ways to do it. The way I usually say is okay, if I have this percent, what does that mean? It means there are 9.54 grams of lauryl alcohol for every 100 grams of solution. Now you're saying, wait a second, I thought there was 163 grams in this solution or something on the other side here. Didn't we have 163? Yes, there was 15.6 grams of lauryl alcohol for every 163.6 grams of solution, but that percentage is the same ratio as 9.54 grams per 100 grams of solution. So in this problem, I'm pretending like we didn't have the data, because a lot of times it's given to you this way. So this is percent. Right? We'll have to say by mass, okay, lauryl alcohol. And so that's what that means. That's the ratio. That percent means there's 9.54 grams of lauryl alcohol for every 100 grams of solution. Well, now we're trying to get to molarity. So we need moles of lauryl alcohol and liters of solution. So now it's just a big unit conversion problem. We have to get the top from grams to moles and the bottom from grams to liters. Some people like to take this problem and like do 2 problems, like do the grams, forget that's there, do the grams, and then put it back together. I just kind of do it all as one. So grams to moles, we did that a minute ago, and that is 186.3 grams in 1 mole. That was given to in the problem. If it wasn't given, you'd have to calculate it based on the formula, but we'll just use that. Now I'm at moles. And grams of solution to liters, 0.850 grams is 1 milliliter of solution. Okay, so this is grams of solution in milliliters of solution. This is grams of lauryl alcohol in moles of lauryl alcohol. So you got to keep the identities straight. Okay, and then there's 1,000 milliliters in 1 liter. And if you do this calculation, you're going to get the same molarity as we got here, the 0.435. Okay, so that's how you would do it if you were given the percent and the density and you had the molarity. You can also go in reverse. You can be given the molarity and you have to work backwards and get the percent. Okay, so that's another thing you could do. Same thing, but everything's in reverse. You would start with 0.435 moles of lauryl alcohol per liter of solution. And then you would just do the unit conversion until you had grams of lauryl alcohol per grams of solution. And then you'd multiply by 100 to put it in percent. So you could do that way too. There's some homework problems like this. Some of them are a little tricky, so take a look at those. Remember, the homework problems are over here, down here. Okay, so that's it for this video. This will be on the next quiz, and something like this will be on the final exam if you're taking it. And that's it. Thanks.